Hello, and welcome back to Quantitative Reasoning Online. We'll be doing the tutorial for 8D. Have my choices affected my learning? To prep for the lesson that's coming up. And then we'll follow up with the questions. No further ado. Adjust it. Alright, so what are we going to be doing in this one? Well, identify points and patterns in a scatter plot. Find and interpret the slope of a line from an algebraic equation. Determine whether the scatter plot has a positive or negative regression value, correlation value. And use technology to perform regression. We use Excel and a website. So let's see, part 8D, 8 part D. In this class, you will need to be able to read and use a scatter plot to determine the coordinates for a given point and see a pattern in the data. You will need to be able to provide a practical interpretation of the slope of a line and the trend of data. The tutorial for preview of lesson 8, part D begins here. Okay, in lesson 1, part A, that's going back a ways. The class selected the top 3 categories of activities that might affect learning. Your personal data about those 3 categories have been collected by your instructor and will be used in a class for lesson 8, part D. Your instructor will compile that data for discussion in class. Okay. In practice assignment 8D, you need to know how to create a trend line in a spreadsheet and view the statistical information related to the line. I'll show and emphasize Excel for that one. So scatter plot. It's a graph that can be used to display several observations related to more numerical values. So again, X, Y. So basically we're looking at how average income can be used to determine average life expectancies. So again, this is the independent, and this is the dependent. So average income will be used to determine average life expectancy. And here we have there's a plot there. Looks like the more income you make, the longer your life expectancy should be expected. Each data represents a country for these 2 variables, which means this dot here maybe is for country 1 or country, say, 9, number 9. About $20,000, they live about 77 years, while that guy is country listed number, I don't know, 15. Well, probably about $1,000 average income and about average age about 45. So each of these dots represents a country of their average income and their average life expectancy per country. So let's see. Here's a scatter plot on the previous page. For the country that is represented by the dot furthest to the right, approximately the average income and the average life expectancy. So it appears to be about $19,000, and we'll call about 76 years. And round the average income, there's 5,000. Okay, so it's more. So that means like you're 5, 10, 15, 20. So I'm gonna call it 20,000. And there's 10. So again, 10, 20, 30, 40, 76 is close to 80. Country average income, $20,000. 20,000. Let's see. View the prompt. The country indicated by the point farthest to the right. So again, that'd be this guy, which would go along with the 20,000. So that'd be 80 years. So $20,000, 80 years. 80 years. Check answer. My guess is 76. They say 77. Either way, it rounds to 80. Rounds up to 80. So let's see. Next question. Which of the following statements best describes a pattern displayed in a graph? There is no pattern. Definitely a pattern. Something like that. Higher average income are associated with higher average life expectancy. Yes. Higher average income associated with lower. No. So more money you make, the longer you expect to live. Although kind of note, it kind of flattens out after about $8,000. Many graphs of the points of the graph appear in the orders that they are listed. However, not always the case. They do not be in the order listed. And the point you analyze at the far right of the graph is not necessarily the last point in the table. Remember, these are points they're paired. 10, 100, 8, 120, 12, 90. Okay. I mean, it's going to be based on, here's 8, 10, 12. Well, where 10 is, 10, 100, 8, 120, 12, 90. So here was your first data point. Here's your second. Here was your third. It's not 1, 2, 3. It's how the pairing works. Oh, hey, cost of a taxi. C equals 2.5D plus 3.50, where C is in dollars, D is in miles, so if this is dollars, that means this also has to be dollars, because the units have to equal. which means this guy when I'm done has to be dollars. So this 2.5 has to be dollars divided by miles. So after I'm done multiplying these two numbers, miles per dollar, dollar per miles times miles, I end up with dollars. Okay, so state the slope. The slope would be, well, $2.5 per mile. Okay, 2.5. All right. I got ahead of myself. Slope is 2.5, but 2.5 what? What are the units of slope? Okay. Remember, the slope is computed by comparing the changes in the y values to the change in the x values. So, another way of looking at it. So basically, these are my independent. So here's my miles driven. This would be dollars. Dollars. So if I have 2 points, well, your delta y is units of dollars. Your delta x is in miles. Slope is delta y over delta x, which would be units of dollars over miles. So slope, in this case a 2.5, okay, the slope is done by doing a ratio or proportion of change in y values with change of your x values. So that's how we got miles per dollar. I'm sorry, dollars per mile. Getting backwards. Part C, what's a practical interpretation of slope? Well, interpretation of slope, if it's 2.5 dollars per mile, that means for every 1 mile, your cost will increase, because it's positive, by $2.50. The per mile charge of riding tax is $2.50. Cost in dollars, blah, blah, blah. And sub C. Yeah, that's about what we said there. And 3.5, they hint towards this is basically the cost is showing up. So even with no miles driven, he just shows up. You call him, he pulls up to the curbside, and you step in. You have driven 0 miles, but he would have charged you already $3.50 just for the fact that he had to show up to get you. Let's just see for some scatter plots have points that form various lines. Some have points that show a linear pattern but are somewhat scattered, and some form curves. There are other options as well. When two sets of data, XY pairs, form a strong pattern, and we're talking about linear pattern here, they are said to be correlated, and the strength of the relationship is indicated by a number called the correlation coefficient, or just correlation. And we refer to this as either little r or big R, depending on what kind of technology you use. Okay. So some scatter plots. The more it approaches a straight line, connecting the dots, the closest is going to be to 1. Now, in some cases, the sign kind of corresponds to the slope. If we have a negative slope, we have negative correlation. If we have a positive slope, we have a positive correlation. So if we have a positive correlation, it means as we go left to right will be increasing. Negative correlation, left to right, with decreasing. Like I said, closer we approach a straight line with a slope, closer we get to 1, the more of a football we have, the closer we are to 0. We look for like straight lines, or a lot of us try to say a hot dog. Okay, if we can kind of make out a hot dog in the pattern, we tend to have a pretty good correlation. Notice it goes from -1 to 1. Now here's a rub for you. It's an unusual one. What do you think this R would be? It's a nice straight line. I can draw a perfect line through it all. This one's -1. This one's +1. What would that one be? You know what it's going to be? That's going to be 0. Because another thing correlation tells you is how much influence X has on Y, in a very, very general sense. This one say, hey, as X gets bigger, Y values are getting less. For argument 1, as X gets bigger, Y gets bigger. But over here, what's it saying? This one says, as X increases, what does Y do? Y is a constant. So X, in this last case, X has no influence on Y. So if there's no influence on Y, then there's no correlation. That kind of goes along with here. Okay. As X changes, you know what? Y, dang it. Y is pretty undeterminable from value from what X is. Okay. Hope that makes sense. Okay. This is one that trips a lot of people. Hey, it's a perfectly straight line. I can draw a straight line through it. It's got to be R equals 1. R equals 1. No, it's R equals 0. Because no matter what the value of X is, Y is not changing. X does not influence what Y is. All right, enough of that. So, which of the following statement describes the relationship between scatter plots and R values? Scatter plots with a negative R slants up. Okay. Negative, that implies a negative slope. So going left to right, is that going up? No. Scatter plots with positive R values slant up from left to right. Okay, positive R value means positive slope. Going from left to right. Yep. Scatter plots are very scattered, have R values. No. It's got to be this guy. Open, whatever. Open the spreadsheet. Okay, spreadsheet. Column A. Column A looks like carbon dioxide levels in parts per million. And column B is global something. Global temperature anomaly. Interesting. So column A contains carbon dioxide levels in the atmosphere in parts per million at the Mauna Loa Observatory in Hawaii. Column B contains the difference between the mean global between 61 and 1990 down to 0.01 degrees of Kelvin, which is also 0.01 degrees of Celsius, by the way, by NOAA, by NASA and GISS. Okay, in this problem, you use the technology to perform a process called regression. This is a website that you can do things in, so we're going to do, in here we're going to use the website, and the question session we'll use Excel. So let's highlight it, right click, open link in new window. Okay. So let's see. It wants XY values, so let's go to our Excel sheet. So let's do a cut and paste. We'll leave this guy out because they don't want headers. Copy. Paste. This data. Submit data. Oh my. That was quick. And it gives you data. Maybe something you may want to copy down and keep in a notebook for future reference or future use. So we did that. We did that. We did that. We did that. All right. So this guy let's give the intercept round to 4 decimal places. So the intercept. Okay, it looks like it is minus 579.059, round up to 3. 579.0593. Um, 579.0593. All right. Give the slope. Well, here's the slope. On the 4 places. 1, 2, 3. So it looks like it'd be 1.7101. 1.7101. And it was 0, 0, but we had a 5, so we would round up. Now let's scatter plot. It's going to be positive because it is going left to right. It's increasing, so it'll be a positive regression, positive correlation, and I can get into a hot dog sausage type shape. So it'd be a strong correlation. Like I said, not 1, but I'm not sure by what yet. Okay. And scroll down the scatter plot and click on correlation coefficient. All right, scroll down. There you go. Correlation coefficient. And it gives us a 0.8386. Yeah, 0, no rounding. Okay. And the closer it is to 1, the stronger the correlation. Positive correlation above 7 is considered to be strong. 0.5, 0.7 is moderate. Below 0.5 is weak. So we're at 0.8 something. .838. So that'd be strong. All right. Self-evaluation. How confident that you can identify points and patterns in a scatter plot? I'm confident. How confident you can find slope and intercept of a line from the algebraic equation. From the equation, find the slope and the intercept. Extremely. How confident you can determine whether the scatter plot has a positive or negative R value. This is just by looking at the scatter plot. Again, that's kind of seeing how wide of a straight line you can form. And how confident are you that you can use technology to perform a regression? And it depends on technology. So let's see, we identified points, we interpreted the equation, we figured out positive and negative R value, and we performed regressions. Not too bad for this video. All right, so tutorial done. So why don't you, at the completion of this video, go back and go through this tutorial again and play with the technology, play with that website, use that to recreate the numbers again. And with that, you'll see me again shortly, hear me shortly when we do the Part 8D preview questions. Till then, I'll see you later.